Today we're talking about negative exponents. So we're going to get started with today's lesson. Midway through the lesson starter, we've already done the first part of the lesson starter, so we're going to move on to the daily quiz where it said to evaluate. If you remember what evaluate means to find the value of, not solve. You solve the equation. To evaluate a simplified expression. Question number 1 says 10 to the first power. So that's asking for 1, 10. 10 to the first power is 10. 10 to the second power would obviously be 10 times 10, which is 10 to the fourth power would be 10 times 10 times 10 times 10, where if you did that work, you would realize that is 10,000. Take a second and take a look. And you may or may not have already realized this, but I want you to look at the answers to question 1, 2, and 3 and see if you notice a pattern. See if you somehow notice a pattern with 10 to the first, 10 to the second, and 10 to the fourth. See if you notice a pattern with 10 to the first, 10 to the second, and 10 to the fourth. Anyone want to explain whatever pattern that they think that they found?
There's that many zeros.
What do you mean there's that many
So
zeros?
10 to the first power has 1 0, 10 to the second power has 2 zeros, and 10 to the fourth power has 4 zeros.
Now that's really what it is. 10 to the first has 1 0, 10 to the second has 2 zeros. But I don't really want you to know it that way. What I want you to know it is a slightly different way. Don't stop paying attention. Some students at this point say, I already got this. I don't need to know another way to do it. I need you to focus and listen. This is how I actually want you to think of it. Instead of thinking that's how many zeros there are, I want you to think of that number 1, 2, or in this case 4, not as how many zeros, but in how many times the decimal place moves. Here's what I mean. If I take the number 1, this number 1 says I'm going to move the decimal 1 time. For number 2, I'm going to take the number 1, and this time I'm going to move the decimal 2 times. So it's less about how many zeros and more about how many times the decimal place moves. And if we look at the third example, 10 to the fourth, this is really take the number 1, and we're going to move the decimal 1, 2, 3, 4 times. Now, all I'm doing is revealing these zeros that are just sort of like an egg crate, fill in these with zeros, and that's where I get my 10,000. Again, yes, it really is there are 4 zeros, but it's 4 zeros because you take the number 1 and it moved 4 times. Now, I want you to think about that. Think about some sort of pattern that we just recognized. And some of you for number 4 guessed something, and I can assure you it's wrong. I want you to look at number 4 again based on the pattern that we just recognized, we just talked about, and see if you can actually figure out the true value for 10 to the negative 3. And you can certainly talk to your neighbors. I'll give you a little bit of time, let's say 30 seconds to 60 seconds to think about that. Go ahead and talk to your neighbor about what you think is going on. And see if you can somehow figure out the pattern in this equation. All right, so wrapping up some of those conversations, there's really 2 different values that I heard, focusing again on question number 4. Anyone want to raise their hand and tell me one of the 2 values that you got? And again, I heard multiple things, so one of the 2 values that you got?
I got 1 10,000.
1 10,000. Like that? Okay.
Positive 1,000.
So 1,000 like that? Positive 1,000? We'll come right back to you. We'll come right, you think about what you want to say, we'll come right back to you.
Negative 1,000?
Negative 1,000? So 0.01, 0 and 100. Okay, these are the answers I sort of expected to hear. Let's deal with them individually. It's not 1,000. 1,000 would be 10 to the positive 3. That would be 10 times 10 times 10, which is 1,000. Or again, we take the decimal point, we move it 1, 2, 3 times. That would be 1,000. So 10 to the positive 3 is 1,000. This is 10 to the negative 3. Let's deal with negative 1,000. Now I understand the thought process on this. I can tell you it's wrong. But I understand your thought process. Your thought process was, well, I see a negative thing. The negative thing must make it negative. And we'll stress this now. We'll say it again later. Negative exponents do not make things negative. Here's in order to get negative 1,000, what would have to be negative is the base. Like every single time I walked around, you guys were saying a negative times a negative is, I heard you saying that, that's 3 negative 10s. I want 3 negative 10s, not negative 3 of something. 3 negative 10s is, this is 100. This is 100 times a negative 10, which is negative 1,000. So I see where you will get that. It's also wrong. So where do these decimals come from? Where did students get these decimals? Well, if you were listening to what I was saying with these examples, what I said to you was, what this exponent actually means is how many times the decimal place moves. If I take the number 1 and I move the decimal 1 time, that's the number 10. If I take the number 1 and move the decimal 2 times, that's the number 100. If I take the number 1 and move it 1, 2, 3, 4 times, that's the number 10,000. So how is this one different? Well, I'm still going to take the number 1 and I'm still going to move the decimal, and I'm going to move it 3 times, but...
So negatives go left, so you move the decimal place 3 times to the left.
0.001. So you guys were close. I see where you got 10,000 because you're thinking this is 10,000. I see where you got that, but it's 0.001. 1, 2, 3. So it's 1,000. This is 1,000. Now here's another way to look at it, and we're going to elaborate on this further. You guys agree that this number, 0.001, is 1,000, right? This is 1 in the less used thousands place? No? Tenths, hundredths, thousands, this is 1,000? Do you agree that 1,000 is 10 times 10 times 10? Which is the same thing as 10 to the third? And this is 10 to the negative 3. So really, a negative exponent, if we follow our pattern, a negative exponent just takes it and moves it to the bottom. So what a negative does, it doesn't make things negative. It takes this exponent, you move it to the bottom, it becomes positive. This is a concept for some reason students tend to struggle with. We're going to do a couple more examples. I think the reason is because they think all of a sudden, out of nowhere, a fraction appears. But we all know it's not out of nowhere because this is also over 1. So we move it to the bottom, and then this negative 3 becomes a positive 3. Again, we're going to do some more examples of that, but that's more or less where we're going with this concept. So a quick question that was asked. Does the decimal moving thing like this, does this work for all bases? We've only used base 10. No. The decimal moving thing only works for base 10 because if you remember, our number system is called the base 10 system. Base of 10, exponent base of 10. So the decimal moving only works for base 10. But this moving top and bottom, that works for all numbers. And we're going to do some examples of that very shortly. If we're talking about exponents, particularly today we want to talk about negative exponents. This is, we all know, that's the base and the exponent is how many are being multiplied. I don't really want to talk about that. I kind of want to talk about these guys, in particular question number 12. Question number 12, this is not a negative exponent. This is called a negative base. If this is my negative base, negative 5 to the second power is negative 5 times negative 5, which is a positive 25. This, of course, is different while we're on the subject. If I call this question 12a, this is different than if I gave you negative, let's say, 3 to the second power. What's the difference between 12 and 12a? What's the difference? Subtle but important. What's the difference between 12 and 12a? What's the difference between 12 and 12a? Come on, guys, wake up. 12 and 12a. What's the difference between 12 and 12a? The parentheses. There's parentheses in 12. There's no parentheses in 12a. That's a big difference. We follow order of operations, so we do the exponents first. This is negative 3 times 3, which is a negative 9. So big difference. When there's parentheses, I want 2 of the negatives also. Moving along, number 13 is where things get interesting. A negative exponent does not make things negative. A negative exponent does not make things negative. A negative exponent does not make things negative. What a negative exponent does is it takes it, and if it's in the numerator, it moves it to the denominator, and now it's positive. Again, that is a concept that some students tend to struggle with. If it's negative in the numerator, we move to the denominator, and now it is positive. Let's do a couple other examples so that you guys can get my point. Can you please choose a number for a base?
2.
2, great. Can someone please choose a negative exponent, a negative integer exponent? Negative 5. As we were saying, this works for any numbers. How can I get rid of this negative exponent? Well, I move it the whole thing to the bottom, but this time my exponent is positive. That's all you're doing. We're going to focus on the base when the base is 10. I'm just moving it to the bottom and making it positive. Can I have another base? Can someone please give me a base, another base? 4 is my base. Can someone please give me a negative exponent? Negative exponent.
Negative 3.
Negative 3. All I would do is now move it to the bottom and make this a positive 3. Now, of course, I would have more work to do, like this would be 2 times 2 times 2 times 2 times 2. I could do more work, etc. But right now, all I want you to focus on is going from this step to this step. So let me do 2 of them. I want you guys to just focus on moving them and making them positive. So please do that one. Go ahead. This one is 1 over 8 to the positive 6. Let's do another one. 12 to the negative 3. Go ahead and do that one. This one would be 1 over 12 to the positive 3. Let's do one last one. Go ahead and do that pink one. This would be 1 over 5 to the positive 4. Good news and bad news. Bad news is we're going to do more than just do this. So I'm going to do something along this line. That's the bad news. The good news is all of these bases, 2, 4, 5, 12, and 8, the only one I need you to know is base 10. So speaking of which, please do what I just did on 13. Do that on 14 and 15, please. These are probably 3 important ones to know. By probably, I mean definitely. So I'll put some star next to them. 10 to the negative 3 would be 1 over 10 to the positive 3. And this one would be 1 over 10 to the positive 4. Now, of course, we also know, going back to this original one, we know that 10 to the second is 10 times 10, or really 100. Everyone agree with that? Please write this one, do the same thing for this one and for that one, as I just did. Well, 10 to the third is 1,000, so this is 1 over 1,000. And 10 to the fourth is 10,000, it's 1 over 10,000. And then going even further, I I know that 100th is 100th. And these are all things you need to have committed to memory. You need to know how to go from this to this to this to this, particularly for your test. Please do what I just did for number 14 and again for number 15. So 1,000 is tenths, hundredths, thousandths, and 1/10 thousand is tenths, hundredths, thousandths, 10,000ths. Again, these questions you should have committed to memory. Just to sort of finish off the concept for you, if we go 10 to the negative 1, that's 1 over 10 to the positive 1, which is of course 1/10, which is 1/10. And if we go even further, 10 to the 0, anything to the power of 0 is 1. So if you notice, see how the decimal is kind of moving along? It didn't move 0 times in that case. The decimal moved 0 times in that case. Something for you to remember is, again, a negative exponent moves into the denominator, it does not make things negative. A negative exponent moves into the denominator, it does not make things negative. A negative exponent moves into the denominator, it does not make things negative. And the last thing is just to sort of show you different things they like to ask on the SOL. They may start with 10 to the negative 3, and then they'll say, is this the same thing as that? Yes, it is. Is it the same thing as this? 10 times 10 times 10?
Yeah.
Yes, it is. Is it the same thing as this? 1/10 times 1/10 times 1/10?
Yes.
Yes.
Yeah, it is, because 1 times 1 times 1, 1/10 is 10. Is it the same thing as this? 1/10, the whole thing to the third power.
No.
Yeah.
Yeah, because it's 1/10 and another 1/10 and 3 1/10. It's just different ways that you might see the same things, just so you guys are aware, in case they should have that question on the SOL, be prepared for that.